Hi, it's Mr. Mac, and in this our next series in Math Skills You Need, we're going to be learning how to write numbers in scientific notation and then how to round them to a certain number of significant figures.
This is Mr. Mac. He can explain things really well and is a lot of fun to watch. You can subscribe to Mr. Mac's Physics channel. You will find mathematics problems, science demonstrations, astronomy and space pics, physics calculations and simple explanations of advanced concepts.
Now, whether you're a scientist, an economist, a statistician, or in one of the health professions, you will often need to work with very large or very small numbers. So we're learning to use scientific notation, sometimes called standard form, with a required number of significant figures. And we'll be able to write numbers in scientific notation and round to a certain number of significant figures. So here's worked example 1, writing large numbers. We can write any number in scientific notation a times 10 to the power n, where a is between 1 and 9.9 repeater. That is where a begins with a digit of 1 to 9. So when we look at the full moon, we're reminded that the average distance to the moon is 384,400,000 meters. Now, we don't need to write out all those zeros when we use scientific notation. We do need all the other significant figures. So our first step is to write them down, 3, 8, 4, 4. And our second step is to place a decimal point after the first digit, 3.844, and work out the number of places the decimal point moved. As you see here, it moved 8 places. And then we write down times 10 to the n, where n is the number of places. So we have 3.844 times 10 to the 8, and of course we don't forget the units, meters. And that is shorter than what we had in the original question. In work example 2, we're going to write small numbers. The size of a plant cell is about 0.0000125 meters. Again, we don't need to write out all those zeros when we write it in scientific notation. We do, however, need all the other significant figures. So we write them down. 1, 2, 7, 5. And again, we place a decimal point after the first digit, 1.275. And we work out the number of places the decimal point moved. In this case, it moved 5 places to the right to make a very small number. And we write down times 10 to the n, where n is the number of places. 1.275 times 10. This time it's to the negative 5. And remember, it is a negative power because it's a very small number. Worked example 3, we'll look at rounding. We may need to round a number that has too much precision for our needs. The speed of light is 299,792,458 meters per second. That's precise. We usually don't need 9 significant figures for most of what we do. We don't need that level of precision. So let's round it to 4 significant figures. Well, first we write down the first 5 significant figures. That's one more than we need. 29979. And then we place a decimal point after the first digit, as we did in the previous example, 2.9979. And then we look at the 4th figure to see if it needs to be rounded up or if we leave it the way it is. Remember, if that 5th figure is a 5, a 6, a 7, an 8, or a 9, then we round up the 4th digit one more place. So 2.9979 becomes 2.998. And then we work out the number of places the decimal point moved. and write down again times 10 to the n, where n is the number of places. And in this case, it's 2.998 times 10 to the 8, and you can see why it's 8. It's 8 decimal places that the point has moved. And we put in brackets 4 sig fig to remind us that we have rounded it to 4 significant figures. Worked example 4, we're going to calculate and then round. And this is a very small number. Electrons have a mass of 9.1093888 times 10 to the negative 31 kilograms, correct to 9 significant figures. Now, a proton is 1,836 times the mass of an electron. And the question is, calculate the mass of a proton, call it MP, correct to 4 significant figures. So firstly, we do the calculation. There it is, MP, 9.1093888 times 10 to the negative 31, and we multiply that by 1,836. And we need a calculator to do that. And when we do that, we end up with lots of digits, 1.672482513 times 10 to the negative 27. And that's not our answer, because we need to round it to 4 significant figures. So first of all, we write down the first 5 significant figures. That's one more than we need. 1, 6, 7, 2, 4. And then place a decimal point after the first digit, 1.6724. And then we look at the 4th figure to see if it needs to be rounded up. Remember, if it's 5 or above, we round up, otherwise we leave it the way it is. In this case, 4 is lower than 5, and so we leave the 2 just as it is. And we look at the number of the power in the question, and that's negative 27. And we write down times 10 to the n, where n is the power, and we end up with MP equals 1.672 times 10 to the negative 27 kilograms, rounded correctly to 4 significant figures. And that's how we calculate and then round using scientific notation. So we've seen how to round to a certain number of significant figures using scientific notation. In our next video, we're going to see why that's so important when we look at errors of measurement. I'm Mr. Mac. Thanks for watching.